Hi, Chem Peeps. Let's do some examples of writing net ionic equations from a molecular equation. So I'm going to move this up so we have a little more room to work with here. So in the first example above, we have an equation that we have to convert into a net ionic equation. This is part 2 of a series on net ionic equations. So please find my first video that explains the different parts. But notice there are 3 aqueous solutions and they're ionic. And I know that because the compounds are metal with nonmetal. And then I also have a solid as a product. So this is going to work perfectly. So the first thing that I need to do is I need to break down my compounds that are aqueous into their ions. I am going to leave the solid intact. So in the next line, the complete equation, I'm going to bring this 2 up in front for the sodium, is 2 sodium ions, and it's aqueous, and 1 carbonate, and you may have to get an index out to remember all the charges. I'm just going to quickly write this, and then we have a magnesium ion, and a sulfate polyatomic ion, and this 2 is going to come up in front for the sodium, 2Na plus 1 aqueous and sulfate polyatomic ion. And I'm just going to rewrite my solid in this case as it is written, as such. Okay, so this is a complete reaction. We want a net. In other words, we want to take the spectators out. The spectators are what is common to both sides and are really not participating in the reaction. So the first spectator is sodium cation. The second spectator is the sulfate polyatomic ion. So those are going to come out of the equation. And so the net ionic equation is just what remains. So we have carbonate ion plus magnesium cation produces magnesium carbonate. And so this is truly what's going on in the beaker as everything's floating around in there reacting. And so this is our net ionic equation. Let's look at the next example. In the next example, we have to first predict it. And so we have 2 aqueous solutions. I'm just going to put the charges of these polyatomic ions and cations and anions down. And this is a double replacement reaction. And what's going to happen is the ammonium, which is a positive, is going to replace with the calcium. So on the product side, we're going to put calcium with phosphate. And we're going to have to do cross down. So if we look at the charges and we cross down, we're going to have a 3 here and a 2 here. And then I'm going to pair the ammonium, which is a positive polyatomic ion, with the chloride. Okay, and they're 1 to 1. Now, we need to look at our solubility rules, which I should really do a video on that. Solubility rules predict that this is going to be insoluble. It's going to form a solid, which is important. I told you that up here, that you need a solid, liquid, or gas on the product side for this to work. And then this chloride compound is aqueous. So the next step for us is to break apart all the aqueous. So we're going to break the aqueous compounds apart into their ions. And then we're going to rewrite them. So I'm going to have 3 ammoniums, aqueous, and I'm going to have 1 phosphate with a -3 charge, aqueous, plus 1 calcium cation, aqueous, plus 2 chlorides. I bring that 2 up with a -1 charge. And then I'm going to leave the solid intact. That's important. It does not break apart in the equation. And then we have ammonium. And I'm not going to write the aqueous out because I am running out of space. I'm just going to throw in the chloride ion here. And so our next step is to take out the spectators. So what's common to both sides? Whoops, I forgot to balance this equation. I need a 3 here, so that means there's a 3 in front of these two. Oops, and you know what? I think that is going to be wrong because I didn't balance my other ones. So I am going to put a 3 in front of this one and a 2 in front of this one, and that will make this one have a 6. So we're going to have 6 ammoniums plus 6 chlorides, 6 here, and then that's going to change this to a 6, and this to a 2, and this to a 3, and this to a 6. And that's important because if I hadn't balanced it to begin with, I am not going to be able to take them out of the equation completely. See, I have 6 ammoniums here and 6 ammoniums, so all of those come out of the equation. I have 6 chlorides here and 6 chlorides here, and that takes it out of the equation. And so what is remaining, let's see if I can, I'm going to just make that smaller so that I can write. What's remaining is 2 phosphate ions, or polyatomic ions, plus 3 calcium cations, aqueous, to produce calcium phosphate, and it is a precipitate or a solid, and that would be my net ionic equation. I hope this helps. Find me on TikTok and YouTube at Chemchat, and I'll talk to you later.